In the last lesson, we looked at how we can slice through one-dimensional arrays. Before we can slice through multi-dimensional arrays, we should learn how to reshape them. Creating a 1D array is very simple. We've done it many times before. First, we'll import numpy as np, and then we'll set some variable x is equal to numpy.arrange 9. The array will have 9 elements that range from 0 to 8. And clearly, if we print this, print x, it prints a simple, boring one-dimensional array. We can actually reshape this into a two-dimensional array. Reshaping does not change the data or alter the data in any way. Our array will still have 9 elements from 0 to 8, except now we'll reshape it to have 3 rows and 3 columns, all of which still contain the same data. You can do this by simply calling .reshape3 and 3. Print the result, and clearly it's a 3 by 3 array, 3 rows and 3 columns containing our data. If I tried to make this into a 3 by 5 array, we'd get an error, which makes sense since a 3 by 5 array implies 15 elements. We only have 9. Remember, the new shape must define an array with the same total number of elements. Your dimensions must be compatible with the data. If I were to actually put -1, which denotes an unknown dimension, then the amount of columns in this case is determined such that the overall number of items in the reshaped array must work out to 9, given that we've already specified 3 rows. If we run this, it's going to work out to 3 columns, like we had it previously. We can actually take this one step further. Instead of just 9 elements, we can make this into 18 elements, and we'll reshape this array to be 2 by 3 by 3. Go ahead and print this. Clearly, this array has 18 elements, 0 to 17, and we reshaped it to have 2 blocks of data, and each one has 9 elements shaped into 3 rows and 3 columns. In total, this corresponds to 18 elements. The best way to think about this is imagine an Excel spreadsheet with 2 sheets, and each sheet has 3 rows and 3 columns. Alternatively, we can reshape our one-dimensional array into a 3 by 3 by 2 array. Print the result, and we get 3 blocks of data, each one with 3 rows and 2 columns. The take-home message being is that reshape changes the shape of an array according to a tuple of integers. The new shape of that array, its new dimensions, must be compatible with the array's data. Otherwise, an exception is thrown, as we previously saw. Now we can proceed into the slicing and indexing of multi-dimensional arrays, and we'll do that in the next lesson.